There we go. Welcome everybody to Claigan's webinar, our webinar on the U.S. TSCA PFAS reporting. It's a lot of acronyms. United States Toxic Substance Control Act, Perfluoroalkyl Substance Reporting. Webinar by Claigan, us. I'm Bruce Calder, I'm the VP of Consulting Services here at Claigan, and I'm going to be your host today. And I'm going to talk about U.S. TSCA PFAS reporting, but it's going to seem off the bat I go for a bit of a wander, though I sometimes do go for a bit of a wander. I'm going to talk about some upcoming deadlines, in particular, obviously the PFAS reporting, both in Maine and U.S. federally, but I'm going to talk about a couple others. And then I'm going to do a public service announcement type thing on a problem with the ROHS exemption formula sheet. The official formula, the official tracker of ROHS exemptions maybe still has a formula issue and it caused confusion. And then talk a little bit about our PFAS submissions, explain what we did submitting to the EU and the US to understand a little bit of the data set we're working from. And then I'm going to talk about the main topic, US TSCA PFAS reporting, the deadlines, where you're going to find PFAS in your products, what the reporting requirements are for articles. We're going to talk primarily on articles and its data format, the streamlined form. Chemical reporting is theoretically a little bit more challenging, but it isn't really. It's a lot easier on the chemical side. But there's a different form for reporting the chemicals and articles. And then I'm going to talk about how you actually do it, how we do it, and how we try to set it up so you can do the federal reporting, you do state level reporting, you do Canada when it comes online for reporting, and then how you handle the upcoming PFAS restriction in the EU and its different derogations. How do you understand how it impacts you? So we try to make a data set for PFAS that is very, very useful. In fact, you can use it for many, many things. And then we'll do a Q&A at the end. So the idea here is to do this about 50 minutes with about 10 minutes of Q&A at the end. So a lot of deadlines coming up. Of course, we're talking heavily on the PFAS reporting side, especially the US federal for most companies in May of 2025. But in January 2025, pretty well everyone has the Maine reporting, the state of Maine. Minnesota is start of 2026. One of the ones that's a dotted line here, still in draft form, that's going to dwarf these, is a Canadian requirement. I think the year-end 2024 has reported September 29th, 2025. You have to report all plastics in your product in Canada. So it's a draft version. So it's all plastics, not just PTFE. It's all plastics in your product. It's not just the PFAS, it's everything. Now it's still draft, we'll see how it goes. But in Canada, their reporting requirement for 2025 is all plastics. Polyethylene, polyurethane, all urethane epoxies, everything. So that's now, of course, just as the chemical, not every single instance of PTFE or polyethylene or polyurethane or polyolefins, but all the plastics. And as the years go on, in future years, like how much do you recycle, and if they're recycled in future years, what happens to them? So that one's going to dwarf these ones, but we're still talk with PFAS today. So today we're going to talk about PFAS. Canada their reporting requirements going to be for all plastics. And it's a very Canadian, definitely reporting. It has lots of great definitions, like it has to define what a maple syrup tap and pot is. It defines what a snowmobile is. It defines what different types of fishing lures are. It's easily the most Canadian regulation you've ever seen. What's a snowshoe? So on and so forth. So they define electronic equipment, like the ROHS definition, but then they also go on to define things like maple syrup taps and different kinds of jiggers for fishing and lures and this, that, and the other thing. It's quite unique. So it's still draft form, very unique. And again, if you've walked over the beaches on the ocean here in Canada and stuff like that, the amount of professional fishing gear that's washed up on the shore, nets and stuff like that, it's usually quite dramatic. So you can see their point on that. I'm not sure what kind of waste level maple syrup taps are, but they're definitely on that list too. But it also includes all electronics. So for the 2024 year reporting in 2025, September, you theoretically, if it goes through the way it is right now, with Environment Canada and climate change, you have to report all the plastics in all of your electronic products. Should be something. So first right now is TSCA PFAS reporting. So before we get into that, this is sort of the public service announcement. It just caused so many problems. I think they might have fixed it by now, but it has been a bit of a problem. So ROHS is a directive, not a regulation. So since it's a directive, it's controlled by the EU Commission. The EU Commission is made up of the elected governments of all the different member states. but it's run by the elected governments in a combination, but it's not an agency or really, it's organized, but it's not quite the same as a professional organization. REACH is a regulation, therefore it works, it has used EU agencies like the European Chemical Agency, or ECHA. And by using ECHA, there's a professional organization who handles like the REACH consultations and the new restrictions. The ROHS is kind of a forgotten stepchild, but the Commission controls the exemption process. It's a delegated power they have in the ROHS directive, and they'll have it until the directive is someday rewritten into a regulation. Once it's rewritten into a regulation, it'll be moved over to the European Chemical Agency, all this exemption stuff. But right now, the official tracker for the status of exemption is an Excel sheet you can download and that link above. Whenever you see that kind of purpley blue underlined, that's a hyperlink. And so in the slides when we send it, you can go and download the Excel file. Depending on what version of Excel you have, it may not interpret the formulas in it. The tracker has formulas in it. And if it doesn't interpret it right, it's going to look like a bunch of exemptions have expired. Remember, the ones in renewal were proposed to change or expire in 2024, but it was never published, so they actually don't have an expiry date. So these exemptions, which have been some kind of renewal since 2020 timeframe, 3 to 4 years now, are still valid until they published an answer, which they likely won't do until they actually rewrite ROHS into regulation. Until they publish an answer, are still quite valid. However, if you use the wrong version of Excel, the formula to do all that, a conversion, doesn't work. And you end up looking like you have exemptions expiring in 2024. But you don't. So if you uploaded the right version of Excel, or Google Sheets has the right version, you should have a formula that activates, and you see a whole bunch of colors on the right side. If you get colors on the right side, it's working. And you'll see a lot of the exemptions are the ones you mostly care about are still in some kind of renewal process. And they'll continue in this oblivious, you keep using them, probably until ROHS is rewritten as a regulation. That'll involve new law, which likely won't happen before the EU elections next year. Just so the ROHS exemptions, there's no end to them. The ones that are renewal, they're on a happy course, or whichever, forward, and probably until their changes are published, which likely will work through some kind of consultation plan as part of ROHS becoming either its own regulation or part of REACH, one of the two. So again, one of the things we did, huge project on PFAS, so 30 or 40 companies, we created these consultation submissions to EU. We amalgamate all this test data we have and all this information these different industries have, fabric and medical and consumer and professional and cooking and the actual raw chemical suppliers, component manufacturers, and a huge range of companies, and put data together to give to them. And one of the problems the EU and the US, they've been using a lot of the same data or hypotheses that are completely wrong. Almost every time we read some article by them or by the news, the first thing they start talking about is, PFAS and cookware and firefighting foam. It's used in many, many other places. Your Teflon pan has one PTFE part, that one. Your laptop in front of you will have 2 or 3 dozen PFAS parts in it. It's a different level of impact. And nobody's really tested it properly. So we provided them the 2023 test data. This is where things are in articles. The idea is, like, if you're going to do this, realize you have to keep track of all these things. We provided them a chart. We actually broke down and explained each use. Then we explained the PFOA side. So what's been found in water supplies and humans aren't PTFE. They're a handful of water-soluble salts. And a lot of people say there are thousands of PFAS. Oh yeah, and I can show you why mathematically and why there are thousands. But all the degradation products, all the ones that happen in water, all degrade into about 14. There's only 14 that really matter in the water side. All the rest are pretty superfluous, because that's the point of forever chemicals. They'll keep degrading until they get to the forever side. So no matter what you start with, even if they haven't fully degraded, you'll see the forever part, because that's the part that stops moving. And it's very different. So the PFOA is never added to a product. It's a degradation of another substance, usually very specific polymers in makeup or in irradiated polymers, or there's a handful of fluoroacrylics, the waterproof coating on fabric, or PFA, the wires in your laptop in front of you, that for chemical structural reasons have PFOA in them, and it degrades. So we explain that this is the test results, and this is where we're seeing it, so they understand where we're actually seeing PFOA and PFOS. We don't see PFOS family very much. We only see one. There's only one sulfonate that you really should know about, and that's 6,2-FDS. If you don't know what 6,2-FDS is, you haven't tested your product. And if your suppliers aren't telling you about 6,2-FDS, your supplier data is junk. It's probably the most common of the water-soluble PFOS and PFOA family. PFOS family, only 2 exist, and one degrades super fast. One, the PFBS, can be used as an anti-hazing agent in your screen on your laptop, but it's so low concentration you can't see it. What you normally only see is the 6,2 flatelimar sulfonate, which when I show that, people don't recognize it. So I didn't put it here, but it's actually the most important one to know. If you're doing data gathering and you don't have 6,2-FDS data, then it's not worth it. That's probably the easiest solution. If you don't have data on like 6,2-FDS, your data gathering is not working. It's the most common degradation product. It's regulated in drinking water, not much else yet, but it will be banned in the upcoming PFAS restrictions, depending on the derogations. It's constituent in almost all fluoroelastomers, FKM, FFKM. That's a whole big reason for that. So we explained all that to them. And it's funny, PFOA is very material based. Like, we know exactly where it's going to be because of the material. It's actually very straightforward, very predictable. Then we want, okay, so you guys are all worried about PFAS. Before alkyl substance, a huge, huge family which have only moderate relationships to each other sometimes. But what's being found in the news articles and say, we found PFAS in humans, and PFAS is being linked to lower fertility. It's not PFAS, it's the water-soluble PFOA family. It's not PTFE. So what we did is we had chemists, not journalists, who are making headlines, not academics. So one of the things about academics is like, hey, academics are not this happy strawberry shortcake, lovely people in a room necessarily. They're very much like the Kardashians. They need publicity. That's their funding, their grant, their success. All of that has to do often with publicity. So if they're going to test for PFOA in the water, they're going to make darn sure they test once, at least at the airport, at a firefighting station, where they practice with firefighting foam to get a ridiculously large result, which makes sense, and then say, hey, look how high concentration it is. Or they'll say, wait, we found PFAS. You cracked out not only the most sensitive parts per trillion machine possibly could, the actual elastomer seals in some of the water plants and so on and so forth will have this PFOA families in them, and they'll contribute to it. So it's always a little bit interesting. They always have like, oh my God, look at this horrible thing. But if they don't make it big headlines, nobody's going to pay their bills. So very much a lot of the academia is very much like Kardashians. And the journalists want headlines. They need clicks. It's the easy way to put it. If people don't read their stuff, they don't have money either. I mean, a lot of this is follow the money. So instead, we took a chemist who doesn't have the same motivation. Now, a journalist or an academic might be more likely to be, invited to a dinner party than an industrial chemist. At least I'm using that as an excuse in my case. But we had a chemist go through it all and say, hey, let's look at every news article that quotes a science paper for the last couple of years and see actually what's in the science paper. And we looked it up and went, hey, wait a second. As expected, what they're finding in humans drinking water isn't PTFE. It isn't your FKM fluoroelastomers. It's the PFOA family. Sweet. And if it's a firefighting place, 20 years ago, they had a PFOS firefighting foam. So, and they'll always find a way to squeeze one of those in because you want a big number. So they always find a way to like, hey, we measured this place, and funnily enough, the burn pit at the airport. Yeah, you're doing that to get an extraordinary number. So they had all the results. We looked at, okay, are we finding PTFE in humans? No. All right. Are we finding it in water? No. So we're finding the PFOA family? Yes. All right. So we should look at the materials that causes degradation. Sphere isn't PFAS. It's the PFOA family. It's the forever chemical that does affect your kidneys. PFOA affects your kidneys. It's a very powerful surfactant, which is detergent. It's like your laundry detergent. It's weaker than your laundry detergent. It's like 10,000 times weaker than your laundry detergent, but it's 1,000,000 times lower concentration than your laundry detergent. Laundry detergent is a lot worse, but it affects your kidneys and affects the surfactant in the kidneys, which causes kidney damage. And then it causes lesions in the kidneys, which is kidney cancer and other kidney functions. Your kidneys are a poison filter. If it goes toes up, then the rest of your body's going to go sideways. So they often say, hey, PFOA is related to all these things. No, when we inject it in rats, it takes their kidneys out. You take their kidneys out, then your heart and brain are going next. So it can say it causes all these problems. No, it causes problems with the kidneys. The kidneys are poison filter for everything else. But with key cut, also one of the fundamental parts is every news article talking about what they found in humans, they start talking about cookware. Cookware does not contain, nor does it produce, a single PFAS found in humans or the environment. It's not the source. Makeup pre-2021, sure. Firefighting foam and the limited use of it, you don't see a lot of. How many times in your given day have you seen somebody with foundation or concealer on their face versus how many times have you seen somebody spraying a fire extinguisher? So, let's be realistic here. Pre-2021, before PFOA was banned, and they used basically a PFOA precursor in almost all concealer and foundation, sure, that got into everything. You think 5% of the population is washing it down the drain every day. It adds up. Cookware doesn't contain it, nor, no matter how hot you get it, it doesn't degrade into it. It's not the problem. It's funny, at home, we use lots of Teflon, and we have a chem lab, we know lots of things. We use the Teflon all the time because it protects us from aluminum, because all the aluminum attaches to brain cells and causes cell suffocation, which leads to things like Alzheimer's. So we use Teflon to protect, or instead of aluminum foil or other things. It's just chemically safer. Because Teflon in its normal state doesn't have any of these bad things in it. It's perfectly benign, very biocompatible. And that's one of the things that came on the news articles. A lot of things that you guys are thinking or saying and why you're regulating is completely wrong. There are sources, by the way, but not the ones you're quoting. So then we also explained alternatives and say, hey, if we need, they're like, well, why don't we get rid of it anyways? Like, who really needs it? So we actually put a matrix and say, hey, here are all the different polymers and all the different fluoropolymers too, and their pros and cons. And it actually becomes pretty self-explanatory why you need a lot of these things. Well, we don't want oil pipelines, gas pipelines that might leak. Yes, so you need a fluoropolymer in there that can handle the chemical resistance. Or, okay, well, that's oil and gas. Okay, you have a hard drive in a computer. Do you want humidity to get inside it? No, you need a fluoroelastomer. You can put silicone. Silicone's a little water resistant, but not greatly. You'll eventually get through. PTFE is greatly water resistant. It's actually hydrophobic. It repels and keeps it abroad. That's a really good reason. Or right now, your computer, your laptop in front of you. Your laptop doesn't exist without it. You're like, well, what do you mean? There are alternatives. Okay, let's say, I don't know, you have a processor there and a screen there. Processor, screen, processor, screen. You have to get information from A to B, processor to screen. The processor goes really fast. It gets very, very hot, extremely hot. And it works really hard. Because of that, you can't use PVC wiring in it because the PVC can't take the temperature. They're like, well, what do we use in a stove? Use silicone. Like, why can't we use silicone? Because silicone is really thick wire. It's not very good at being thin. And so silicone doesn't make for good wire in there. It also doesn't bend properly. If you ever try to bend silicone, it doesn't really like to keep those shapes. So you have to use a fluoro. I'm like, oh, use PTFE wiring in your computer. No. You're like, basically, where are you going with this? Okay, so PTFE, if you ever take your fry pan, touch it, how soft is it? Is your frying pan rubbery in the top? No, goodness not, it's solid. PTFE, normal state, is very, very long. I really should have more slides in this, but I'm gonna need to talk to my hands. Very, very long polymers. There are many, Timothy Dalton's, it's real, it's not James Bond guy, it's Dalton's. Long, and basically most polymers, polycarbonate included, the longer the polymer, the more rigid it is, the harder it is to bend, and PTFE is a very, very long polymer. So its normal state is very rigid, which makes for pretty piss poor wiring because you can't bend it. If it's inflexible, then it's like, let's take the long way around. So in your computer or your phone or your tablet, you need wiring that can take the temperature and also is extremely flexible. That's where you bring in PFA, perfluoroalkylalkane. It's a different fluoropolymer than PTFE. And it has a bond structure with a carbon-oxygen-carbon, and in a long hole discussion, it breaks down into PFOA. But you need that wires to attach to see the picture you're seeing right now. Without it, in that congested, dense, you ever take your laptop apart, you'll see it's extremely dense in there. You need the PFA wire. And normally that PFA wire will have PFOA, which has exemption briefly right now in the EU, but may be banned in the future. But there's a reason for it. So going through every single material, like, why can't we use silicone? Silicone is a poor replacement for almost every other material. It's like the cheap solution that doesn't really do anything properly. Is it hydrophobic, water repellent? No, not really. It's water resistant, but it's not water repellent. Is it oleophobic? Is it oil resistant? Goodness no. Oil will go right through it. That's why when you take your spatula and you put your spatula in the dishwasher, it'll come out with every flavor on it. My AirPods case, I know the silicone case, just in case I drop it because I'm clumsy, or I'm talking with my hands, which is also another reason why I drop it. My silicone case, if I ever cook Indian, which I did last week, that silicone case will smell like it forever because it sucks up the oils in it. Silicone can handle high temperature, which is good, but there's also a number of other chemicals it can't handle. Stainless steel, by the way, can't handle high acids. Can use a stainless steel seal. Stainless steel is not very compressive, so it doesn't do a lot of the proper seals you need, and actually has trouble with very strong acids and eventually eat through the chromium oxide protective layer, which protects it from vinegar, but won't protect it from hydrochloric acid, and go right through it. So once you actually put all this together, and by the way, all these are public. They're EU submissions, documents 104 or 105, and I'll probably send out links to them so you can come find them. They're all public information. Shows all the comparisons, and it's most time pretty self-evident why one material is chosen over another, unless it's the cheapest situation. If you don't care what it does, then you're generally not using fluoropolymers anyways. You generally don't use fluoropolymers in situations that you actually care. When you don't care, it's a cheap thing, you don't really care if it works, there's probably not a lot of fluoropolymer. If you care it works, there's more fluoropolymers. For example, strangely enough, you have a bunch of labels on your product and on the packaging. There's a couple that are really important. They're like the safety labels and the product information label and the barcode. Chances are they have a fluorolaminate on top of them to protect the ink from running. There's an important reason. You wouldn't be using it just on any sticker, but those ones have to have certain indelibility. They can't degrade. And so from all this, we want to say justify, hey, this is why we need 53 different derogations. So we submitted over 200 pages. And it's fun talking about ourselves and everything. We submitted to the EU on September 21st, and EPA, the US wanted the same thing. And we preferred the US and EPA to have the same information, so we don't have to repeat the whole story again in a year or two to the US on October 13th. There's a way to submit, by the way, if you ever need to, there's a way to submit PFAS information to the US also. And we submitted all these 5 different things. The derogations had 53. These are 53 different applications that are needed in physical products that are justified to continue. There are like 53 different industries. No, they're different things to use it. Fluoroelastomers and seals. PTFE polymers in seals is one thing, but PTFE wiring, FEP wiring are all the wiring is one category. Tons and tons of different applications, fluoroacrylics for safety equipment, etc. These are all applications that are needed to continue functioning, and they're quite justifiable. One of the reasons we submitted all this other information saying, hey, if you really want to see why it's needed, look at all these other things. Fluoropolymers aren't chosen because they want the cheap solution. They're chosen because there's a performance reason. They want a cheap solution, they'll put silicone. It won't work properly. It'll leak and it'll smell, and it generally won't do the same job, but it's cheap. If you need to actually work, use the fluoros. And since the fluoros most of them are the safest materials in existence, they're extremely biocompatible. The only handful, like PFA and the fluoroacrylate coating on your winter gloves, that degrade into PFOA. There's a whole reason for that. And those can be separated. And we did that in a lot of the derogations. These 2 different groupings. The ones that are perfectly safe and the ones that have a little bit of bad stuff. But the little bit of bad stuff is needed for certain things. And it's a little bit of bad stuff. It's not your laundry detergent. That's a lot of bad stuff. So the main topic, after I went for a little wander, and I really should have done it with some slides and pictures and stuff, but is the US TSCA PFAS reporting. Part of it to say, this is really complicated, there's a lot going on. The US wants to report a lot going on back to 2011. And again, that hyperlinked kind of purplish blue will go to the actual final rule. The final rules are a tough read because, so what it is, this isn't a legislation from the US legislature. As it's kind of a little bit obvious, it's kind of hard to pass laws in the US federal legislature right now and has been for some time. It's a bit messy. So what ends up happening is the legislature, when it does pass the law, like when they updated TSCA back in Frank Lautenberg version, I think in 2016, it said, hey, the EPA now has the power to make rules. Those final rules are what what your companies have to follow, are based on very strict legal rules the agency, in this case the EPA, the Environmental Protection Agency, is given. And if they don't follow that rules, their rule can be struck down in court. So basically, they can't create new legislation. However, they create these rules that you have to follow as long as they follow the rules they were given in the original legislation back in 2016. So what the main part is they have to say, hey, this is what we proposed. This is what the feedback is. This is how we're addressing the feedback. This is how we're handling small businesses. This is how we're addressing costs. And all that has to be written in there. So it ends up being kind of a wander. Sometimes the final rule, they create a fact sheet like they did with the HFC phase down. That one has a fact sheet. It's great. It gets the salient points. This one goes for a bit of a wander. It's a bit tricky to figure out where the actual rule is. When in doubt, look for the word streamline or streamline. That will give you the key salient bits. It's the detail, the data requirements, the streamlined form. The streamlined form is the form that article manufacturers, physical product manufacturers will have to fill in for all their stuff imported or manufactured back to 2011. And the deadline for this is if you have over $120 million of sales, including your parent company, it's May 8th, 2025. If you're under 120 million, it's November 12th, 2025. There's some other caveats, but the other caveats are pretty rare situations. So it's really these two. Now, if you're FDA regulated, you're not in scope of EPA. So medical devices, which may or may not include their packaging. Pharmaceuticals and medical devices are FDA regulated and out of this. Is their packaging? Nobody seems to have an answer. Food contact materials are FDA, so stuff in contact with food are FDA regulated or out, but the rest of food contact appliance is in. So the refrigerator, the shelves can be seen as food contact because you could put your lettuce right on them. However, the rest outside of the shelves and main internal shell of the refrigerator are in scope because they're not FDA regulated. Medical device, the whole device is regulated. Is the packaging? Good question. And pharmaceutical, it's a big deal because a lot of those labels on the pharmaceutical have to have, they can't, in humidity, have all the writing run. So they're mostly floral coated. So a lot of pharmaceutical packaging in particular has a lot of floral coating on it, which is reportable. Is that in scope of this? Nobody seems to know. Probably, but it's not clear either way because the medical device exclusion is from it's actually from a letter which is scanned in from decades ago in a slant and everybody uses. But when we do the reporting, a system called CDX, which will come up later, there's actually, you can actually report for medical device if you wish to, but you don't have to. Actually list them as non-TSCA use medical device, non-TSCA use food contact material, right in the reporting requirement. So you can actually report if you wanted to for medical or food contact. You don't have to, but there's the ability to do it, and it actually says non-TSCA. It's kind of neat. Now, the things you have to report. Well, these are physical products. These are some of the most common. Anti-drip agents. So this fellow is probably an ABS polycarbonate blend. It's my AirPods case. To have a high flame retardant rating, like you'd want in your fan, in your computer, or your outer housing of your product, it's basically two rules. You put a candle, actually a Bunsen burner, underneath it, and the rule is if it burns, once you move the Bunsen burner away, there's a stopwatch, and pretty well instantly the burning has to stop. And depending how long it keeps burning is one of the things that defines its flame retardancy. So UL94, B0 or higher, B0 being the highest rating basically. The other thing it has to do when it's burning and afterwards, it's not allowed to drip plastic. So if it drips, not only can it hurt somebody, it can actually move a flaming material from one zone to another, which is a problem. So unfortunately, ABS and polycarbonate are very common housings. They do drip when they burn. They eventually, it's like, stalactite and dripping like you see in a cave. PTFE doesn't. PTFE, when it burns, it creates a webbing. And so what they do is they add about 0.5% PTFE to your average ABS polycarbonate blend. And when it burns, it kind of balls up instead of dripping. And that allows it to meet the flame retardance requirement. So most flame retardant ABS or polycarbonate, especially in housings, have PTFE in it to stop it from dripping. Your very important label. By the way, if anybody's product is here, it's completely random. These are all taken from the web as examples. The barcode label is often, you want it to be so it doesn't degrade. It's often fluorocoated, as is, say, like your hard drive or your power supply, or what has its label, tons of its safety and other product information in it. That's normally fluorolaminated. Most of the time it is. It's not PVC because PVC is hard to write on. Generally, it usually ends up being polyester with a fluorolaminate on top. Dielectrics, so these like your connectors, a little white inside PTFE. Your phone has them, as does your tablet. There's a little flat connector inside your phone or tablet on the antenna. The antenna connection piece has that dielectric in it. It's kind of important for antennas. Release agent, when you make an O-ring, it's made of mold. It would stick to the mold unless they fluoro spray it. They can actually silicone spray it. They normally fluoro spray it. They fluoro spray it. It's either the spray itself has fluorosilicone on it, or the propellant has so much fluoro in it, it leaves some on the surface of the mold. So when you open it, the polyurethane foam or the O-ring or the gasket has fluoro on its surface. And so that's extremely common. Probably a third of all O-rings have measurable amounts. Water-resistant fabric is normally done with a fluoroacrylic coating. It's like a fluoro paint. And it's on not only on the gloves itself, but also like your washing instructions to survive long-term. And they're normally fluoro-coated. So like a little tag in the back, made in China, or your washing instructions are often fluoro-coated. A lot of lenses and your LCD screen in front of you right now often have an anti-reflective or anti-smudge coating. It may be the hydrophobic coating inside of it, or it could be the top coat on top. It's usually fluoro in those particular materials. If you're using fluoro seals, your hard drive use fluoro seals, so water doesn't get in. A lot of your pipes and many other things will use Viton and other fluoro seals. Your test equipment for PFOA uses tons of fluoro seals. They're very unreactive everywhere. And usually FKM, which is Viton, or FFKM, which is commonly called Calres. Those are brand names. Like PTFE's Teflon, brand name. Wires can be PTFE or PFA. More and more often it's PFA, especially medical devices or dense electronics usually use PFA. They normally have PFOA in them and will have compliance problems in Europe on the PFOA side. A lot of metal coatings, the bottom left there, are powder coatings or Teflon coatings, often have PTFE as the main coating or as part of the coating for environmental or friction resistance. You can have tons of PTFE parts. We see PTFE bearings all the time. One that isn't here is we see Kynar or PVDF connections in fluid components all the time. PTFE wraps, we see these tubes and wraps, especially medical devices, all over. But if you have an electronic product and you have a little, stand-up transformer, it's usually got like a yellow polyester tape around it. The little wires coming off it very commonly have a PTFE tube over them because PVC can't handle the temperature in there, so they use little PTFE tubes. PTFE tubes are pretty common, also used in lots of test equipment, laboratory equipment have PTFE tubes because they're unreactive. PTFE tape, that water tape, is also usually PFOA containing because it gets irradiated. If you have PTFE tape in the end of your product, look it up in your BOM. You're 3 out of 4 times you're non-compliant for PFOA in Europe. That product can't be sold in Europe. Basically, if you have PTFE tape, it's 75% chance that product is currently non-compliant in Europe, unless you're a medical device, just because they have until 2025 before they're non-compliant. Everybody else, you're non-compliant right now. You can have PTFE tape without it, but it's actually pretty hard. You have to not irradiate the original powder when they rubberize it. Or what EU says now is you can radiate the powder to make it rubbery. So PTFE is rigid. Take a frying pan, touch it, it's solid. Go home tonight and say you're doing science and start touching your fry pan in front of your family. They'll think you've lost your mind. My family knows they've lost my mind. Have you seen my hair? They got the mad scientist thing going anyway. You touch it and it won't. It's pretty rigid. So to make it rubbery like PTFE tape, you irradiate it, takes these long polymers, breaks them up. The radiation breaks them into little chunks. Those little chunks reconnect into much shorter cross-linked rubber. That's why it's rubbery, quite flexible. However, some of these chunks react with air and create the entire PFOA. If you see PTFE tape, 75% of the time, it's got every single member of the PFOA family, of every single size. You have PTFE tape, you're probably not compliant in Europe right now. Unless you're medical, that's just because it's not 2025 yet. And then often your typical wire with all these cable with all the hookup wires inside, either they're sprayed with a fluoro spray or the machines that they are used to put it together are fluoro sprayed for lubrication. It's common for about 1 in 3 cable bundles, all their hookup wires are fluoro coated, sprayed. It's a light coating. It's related to lubrication either during their manufacturing or if they're lubricated, they flex a lot better and they're far more durable. They don't. The PVC wires don't grip. This is PVC wires. They actually fluoro spray. So if you have bundles of PVC wires, about 1 in 3, they're PFAS coated. Will it appear in supplier information? Probably not. We find supplier information for this is pretty dicey. They say, hey, we get lots of like circuit board components with PFAS in their process. And when we test for it, it's usually below the testable level. And realistically, when we start doing, you see the reporting, none of the circuit board like little internal components matter for reporting. They won't affect your reporting whatsoever. So the data you do get is pretty useless. This is the data more what you need. And you'll see for the US TSCA, the bigger uses are what you end up reporting. The little uses you won't report at all. It's kind of a weird way the system works. So we have a chart, and you can see one of the most, and this is based on 2023 testing data. It's what we submitted to the EU and US. Anti-drip, that stuff that in the housing to make it not drip when it's burning is one of the most common. The release agent in the gaskets and mold is also super, super common. PTFE wire, PFA wire, fluoro-coated stickers, fluoroelastomers, anti-reflective coatings, top coat in that. Pure PTFE parts, pretty common. And because of this, I mean, it's only about 20 here. We submitted 53 different uses of PFAS, which any one of these is only one use, to the EU and the US. There's a lot. This is physical products. These are your typical computers or your electronics. It's very common. Now, sometimes in specialized laboratory folks make laboratory equipment, and IVD have a few others in some of their measurements that isn't common, but 40 of them are pretty common. There's about a dozen or so that are pretty, very, very industry specific. So that's cool. You're like, yeah, you show me pretty pictures. Cool. But what actually needs to be reported? So in the US, you're reporting the PFAS, the chemical that's in products. So you're not reporting your products, you're reporting the chemical that's in your products. Kind of weird. The state level, you're reporting the PFAS in each product family. So you can say, hey, so what is the in Maine? They're still going back and forth. It's likely to be, here's the HS code for refrigerators. Here are the different PFAS in my refrigerator. Suppose the US level, you can say, I have Teflon. This is the maximum concentration of Teflon in my products. This is how many products each year that have Teflon in. Kind of a little bit different. You're not reporting refrigerators. You're in the US, TSCA, you're reporting Teflon, PTFE. Not Teflon's a name brand. You're reporting PTFE. And where are you reporting? You're reporting in CDX. That's your reporting system. By the way, some of you factories might report in CDR. It's a different. They're like, seems really similar. It's like central data reporting and central data exchange. So CDR is a separate reporting than CDX. If you have to do CDR, for something in your chemical process, you also still have to do CDX. I know, great acronyms. You have to report in CDX. A lot of you, if you have factories in the US, might be reporting already in CDR. This is CDX. Same guys, Environmental Protection Agency, different system. Now, this is built for chemical reporting, not articles. So that's why everything's reported at the chemical level, not like the refrigerator level. You report PTFE, not refrigerators. So articles are in scope, but the whole system was built for chemicals. And the reporting form that articles use is not ready yet because they have a new streamlined one. The details of it are inside the final rule. That's why you look up the word streamlined form in the final rule and you get better information. But it's not ready yet, so you can't look at it, but I'm going to explain it. So articles have a streamlined reporting, more or less, in CDX, the system, for article importers, the information that's reasonably ascertainable. Perfection isn't there, and we'll explain, and perfection is not required because also some of their system. The key components is you have to report by chemical, like PTFE, not by product. You don't report, here's my HS code of refrigerators, and this is what's in them. No, you report PTFE, and this is the maximum concentration of my product. This is what it's used for, and this is how many products have. The volume report is not, if it's physical products, it's not kilograms or tons of PTFE, it's the number of products you sell with PTFE in it. So you're reporting PTFE, the maximum concentration of PTFE in your product, what it's used for, and how many products each year had PTFE in them. So it's the use information I'll explain, it's what it's used for. And there are actually pull down menus for it, like lubricant or flame retardant, etc. What's its use? And if you have multiple uses, you break down different percentages, like 25% is flame retardant, another 25% is lubricant, another 25% is dielectric, and the last 25% is as a seal. Probably a different number, but that's how you report it. So reporting requirements are the chemical identity. Again, you report chemicals, not products. You're not reporting refrigerators, you're reporting PTFE. And then you're reporting FKM, and then FFKM, and then PVDF, and each one of the PFAS you have. So you first report polytetrafluoroethylene, which is named PTFE, and its CAS number. Then what's your import volume? Not of PTFE, the number of units containing PTFE each year. So by the way, if you have a remote control and a refrigerator, they're both one, that's two units. I know. How you handle accessories that are alternate parts, we hypothesize what that counts as units. And if you can't figure out, they can't either. And as long as it doesn't change the order of magnitude from 100 to 1,000 to 10,000 to 100,000, they really don't care. What's its industrial use? So if it's imported in an article, it'll usually be U. If you're adding it to your article in the US, there are other industrial processing or use categories, like where you're making the plastic or adding it. Not that you're adding a plastic part with PFAS to your product, that's integration, it's still an article, but you're actually making the plastic coating on your fabric, like you're coating your fabric with it, and that's a chemical coating your fabric. Fluoroacrylate coating your fabric in the US, it's a different use category because it's not integrated, you're integrating the chemical at that point in time. If it comes up and that's a problem for you, we'll walk you through it. This all makes sense to us, more or less. For your equipment, what is your sector, or what's your sector? And there's a pull down menu, and then the product it's basically what's your product category. So you may have to separate them into different product categories, but generally they're very, very large. You just identify your product category. So it's PTFE in your products, this many products, and the distinguishing is not HS code like our refrigerators. It's literally machinery, mechanical appliances, and electrical. Okay. And then the one you have multiples is each functional use, like insulator, friction resistance, flame retardant. They have all pulled down codes, and you have to state the percentage of each. Is it a consumer or commercial? Is it intended for children? And the last one, which isn't on this page, but I'll show on the next one, which it should be, is the most important one, the maximum percent concentration in your product, not of a component of the product, the max concentration. So if you have the remote control and the refrigerator, and you're reporting them together because they both have, say, I don't know, PTFE dielectric in them, the refrigerator probably has many, many PTFEs, and the total amount of PTFE in your refrigerator is under 0.1% by weight of the refrigerator. However, in the remote control, the dielectric, the antenna connector makes it above 0.1%. You end up reporting the above 0.1 to 1% because of the remote control. You report the highest one. So that's why it doesn't really matter how many at this point in time. It's the highest one. That's what you report. And it's basically, it's right here, just above the middle, concentration in product is what you're reporting, 0.1 to 1%. It's the actually SDA, again, this is all built for chemicals, so it's the safety data sheet rules. Under 0.1%, 0.1 to 1%, 1 to 10%, 10 to 30%, and 30 to 100%. That's the pull down, and it's the max concentration. So it's funny, everybody's like worried, the supplier data often comes up with little circuit board components, which is often below measurable levels. But you're going to end up not reporting any of it, because they're all so low concentration. You have the same polymers in much bigger uses in most cases. So it ends up being pretty irrelevant. Most of the data you get from suppliers is fairly irrelevant for this use. The ones you don't get is usually the most relevant. We have a better way to do it. It's just a fast way to do this. So one thing we look at is, okay, so we do a PTFE, what's the max concentration? Once we find what that is, all we know is have to know more or less reasonable breakdown of the uses. 50% is an insulator, 25% is flame retardant, 24% is friction resistance, and 1% is a lubricant additive. And that's what you need to report. And then what's your machinery code? And then you do the same thing with fluoroelastomers, and you do the same things with PVDF. Each PFAS you have is separate. And then it's the number of units each year. And then when you're reporting back to 2011, what we normally do is take, hey, how much did your business really change in these years other than volume? Is your mix roughly the same? So basically the chemical breakdown is not going to change year to year. All that changes is the number of units. So we create this math, and then you basically each year, within reason, identify, as long as the right order of magnitude, the number of units that had PTFE, the number of units that fluoroelastomer. And that's what changes. So your chemical and use breakdown basically stays the same pretty well every year. And what changes the number of units sold. And that makes reporting back to 2011 much easier. Well, I don't have any examples of my product from 2011. I'm not sure what's in it. So basically what you're selling right now, more or less, you just evolved. Yeah, so the PFAS used have been around for decades. It was pretty well the same thing. If you have something that's very different, hey, we use this new reagent that has fluoroacrylates in it, we didn't have it before. Sure, we can always take that one out after a certain date. But it has to really be, we don't have that anymore versus now. So it's usually quite straightforward. And so the way we actually do it is we don't start here. When we test the product, we have a test report which has really specific data, but then we break it out by use. And by use, now we have the data we can amalgamate for state level reporting, which is at like the refrigerator level, or federal reporting, which is the chemical level, or the EU says, hey, we're banning PFAS except for these applications. These are the different applications. So you know, for whatever regulation, you know how you're affected, and can roll it up to what the answer needs to be. So we always do it like a level below, because it's much easier to roll up. The way we do it gives you the information you need to answer any of these. So the way we do it is identify representative products, because we don't need to know, again, you only know the max concentration and the basic breakdown of uses. We don't have to do everything. We just have to be representative. And we test the representative products. It's cheaper and faster than data gathering by a mile. It's far more accurate, and it's a lot easier to attributable from a due diligence point of view. Supplier data is never successfully used for due diligence information unless they provide test reports. It's one of the common misconceptions. If it makes you compliant, sure, but when it comes to a court case or non-compliance, the governments don't care about supplier data. The supplier always says it's good, and they have that opinion. So we also suggest testing for the PFOA restrictions at the same time, because the PFOA, the chemicals and longer that are banned in Europe are only in very specific, and we actually screen pretty well. We know exactly which ones they can and can't be in. PFAS. So once you find a PFAS, it doesn't mean it could have PFOA. Some do and some don't. And we have a very good mapping of that. And then we test the select ones for the PFOA restrictions, proving you do or don't have the PFOA, and take care of that problem at the same time, because that's a ban as opposed to just reasonably ascertainable reporting. So the PFOA restrictions is key. Like, that's a stop ship problem. The others are you might get in trouble and fix your reporting. And then our outputs is we first create the part level declarations, like all the different applications, because this can be manipulated into any use you have. And then we summarize it for the US, and then we summarize it at the state level. It's just mixing the data. And then as the PFAS restriction derogation exemptions appear, it should be self-evident which ones apply to each use. And so you already have that information. So it's really, really good. So we create first the baseline data. Here's the different uses you have, which also has the use information like insulator or friction resistance. And then we blend it up into the federal level ones, which are chemical based. And it might seem complicated, but for us, it's very straightforward. Like, it's a process internally. We do this a lot. You might do this one time. We do this all the time. It's just a lot easier. You get the benefit of the cost advantage of people who do this all the time. So what's the recommendation? What's your next steps? Ask for a quote. Honest to goodness, you'd be surprised how reasonably costed this is. We do it all the time. And we're also representative. We're not trying to figure out how much we can charge you. It's not part of our plan. By the way, if anybody's worked with us before, you probably noticed that if we give you a quote, we might follow up once just to make sure you have it, but we don't bother you or ask you. Asking us for a quote isn't signing up to get, a sales guy to phone you. Are you busy right now? Type situation, every other week. We don't do that. We spend our money. It may not be what is the best business practice, but we've been very successful. We invest our money not in the sales folks or the convincing you or the flashy stuff. We invest almost all of our effort into new process development, stuff that benefits you. We find the sales guy benefits us, but doesn't really benefit you. Following up and making sure you know what you have and you're taken care of, sure. But we put our effort in the technical side. We're not looking to how to spin off the next IPO. That's not our motivation. We never intend to be the biggest. We're not. We're a hell of a lot bigger than we started, though. But we intend to be the best and do a good job. And some of our executives would actually be quite sad, actually, if we didn't actually try to do the best job. It's different motivations for a lot of people. So ask for a quote. Why? It's not a commitment. Asking for a quote is not a commitment. And it's also not inviting yourself to be phoned every week. We don't do that. But it is a solution. It gives you a cost. And you might be surprised how efficient it is. Because it's one of our biggest internal mottos is there's always a better way. And we apply that to everything. There's always a better way to do things. And we have a tremendous amount of process development internally to achieve that. We look at something that was good, and even if it's better, there's usually a better way and get better at it. So ask for a quote. You'd be surprised. You're looking at a major business unit. This work is like $5,000 of work for us. It's not that big of a deal. Now, if you have many businesses, sure, it can go up, but it's really not that big of a deal. Like, it's a very straightforward because how much duplication your PFAS is going to have in your product. We don't care that you have, over your products, hundreds of anti-drip. We just want to know what the anti-drip highest concentration is going to be, which we already know what it's going to be. And we just need to identify it there. It's likely somebody will be asking you how much and how long. If you bring this to your management, and they're like, okay, to do this, how much and how long? We can give you that answer. It doesn't mean you even have to go with us, but we can give you that answer right away. And it isn't some long, complicated process. We're going to exactly tell you what we're going to do, how much, and how long it's going to take. And you don't even have to go with us, but you'll have an answer to how much and how long. By the way, one of the things on the testing side that comes up is like, well, testing is a one shot in time. Well, so is data gathering, and you have to redo the whole blooming thing each time the regulations change. We have a much more straightforward process. We actually plan when we do any testing for you to how we're going to update it for the next changes. And then when we do an update, we plan each year. So we have a 2024 campaign. If we've ever tested anything for you before, we literally have a plan for 2024. Now, medical doesn't have to do TSCA, non-medical doesn't have to do MDR. So there's a slightly different plan for medical, non-medical, but we know exactly how we're going to update the products. It's all planned. We give you lots of details, but actually we say, hey, we've tested your product before. You want to bring it up. You want to bring it up to the current regulation. It's about 25% of the original cost of what you did to bring it all up to stuff. And basically you get a whole extra declaration of all the different revisions and all the bases of it, to what revision of each regulation, what your declarables are, especially the new Prop 65 basically kicked in and coming in fast. It probably is going to be in next year, like completed and published. So about 2 years, 2 to 3 years from now, you're going to have to know all of your Prop 65 subs, at least one to declare. Your warnings will need a substance within 2 to 3 years. We give you all that. We give you the SVHC declaration. We give you, all of your exemptions you're using, et cetera, all in one shot. So you know exactly, and you can provide it to actually even customers. Here's what this product is compliant to what revision, and here are all the declarables for it. And it's set up to just update it. And you don't have to know anything. You just do it. You might say, hey, I've got a product and there's tons of different variations of it. Yes, there's a way to handle that too. Actually, you do a representative product and then you review the bill of materials for the extended to see if there's anything that is technically different in significant way, and then adjust for those handful of significant deviations. It's pretty easy to do it. This is one product, but I have like 200 different variations of it. That's no problem. You do the representative one, and then you look at the bill of materials for the extended. Is there anything in there that radically changes this? And often when it comes down to it, it's not the different products. It's the fact you also have a carrying case. The carrying case for your product is more likely to get you in trouble than anything else. We were doing a variety of work looking at the market for medical devices, but consumer medical devices. Most consumer medical devices look to be pretty decent for Prop 65, but almost all their carrying cases were non-compliant for Prop 65. Things like that surprise you. So again, big recommendation, ask for a quote. Why? It's not a commitment. You're not committing, but it is a solution. And likely somebody's gonna be asking you how much and how long, and we'll at least give you that. So you at least know how much, and sometimes you might be surprised how it's not free. There's work to be done, there's intense work, but the process for us is so set up and stabilized that you get the benefit of what everybody else is doing. It's like when we did the PFAS submissions. You doing that PFAS submission, anyone themselves, 200 pages of technical information, massive endeavor. Leveraging 30, 40 companies of information, it's much better. And you're using processes that everybody else is using. It's just so much easier. Even your own data gathering, you're really doing it yourself. You're not benefiting really from everybody else. You might be benefiting, they might be asking the same sort of questions. This benefits from what everybody else is doing. It's really advantageous. So I'm about on time for questions. Do you have any questions? Feel free to submit to the control panel. If I don't get to questions, please contact me afterwards. This is a really good question. I really like this question. I probably should read this question. It'd probably help everybody else if I did read the question. To clarify, do you believe that medical device packaging fluoro-coated labels need to be reported, or do you think it's optional reporting as non-TSCA? I don't actually know. At a level, I would have thought, hey, the packaging is regulated by the FDA too, but is it? If somebody could point to something, that would be great, because if the device is out, I have no problem with the packaging being out, especially pharma, but pharma will have PFAS. So I don't actually have a good answer for that, because the fact medical devices are out, or food contact materials, it's from very specific things, but it's a very limited scope, and the EPA is definitely all about trying to limit the exclusions as much as possible. So if anybody, and that's a really good one for the medical association or pharmaceutical associations in the US, figure that out. Is your packaging in or out? Because if it's out and somebody can figure out why, that's excellent. If it's in, then you need to do it, because you can have fluoros and some of the warning labels and such. Will TSCA PFAS reporting variables unduly influence all industries, except those that accept in TSCA, when we look at downstream or parallel legislation in the US or state? Have you completed mapping yet of the variables considered for PFAS reporting between federal and state? State ones keep moving around. So until the state level ones create their data set, probably in the interstate data exchange, chemical, it's got a name. It can always change around. That's why we stay at an application level so they can rebuild it to whatever they're doing, which isn't, so the level we keep it at, we don't actually really care what their format is eventually because we have the data anyway. It's just a matter of changing our process in terms of roll up a little bit. So we don't take as much interest in looking at the individual, especially draft data sets. We do a little bit, but we're set up to reprocess into any way they go because it's not the hard part. Once you know what it is, they know PFAS less than we do. So whatever they're going to do is going to be less complicated than we know the actual situation is. So we're not terribly worried about it. Is the total units sold the number of SKUs? It's a total unit sold, which is a very interesting one because if kilograms or tons might have been better, but they don't know the number of units. So if I got a fridge and I have a spare cable for it, how does that work? So we're generally saying any repair part is based on the product it's repairing. If the volume is so high, we might map it in if it changes anything. But at most, it might change the number of units, or we might say, hey, you know, spare parts, every 100 spare parts counts as one product. Maybe. We're not really worried about that because that'll change the units by 1%, which, again, it's order of magnitude that matters. So we're not as worried about that. But it's number of units sold. I thought there's no de minimis for TSCA PFAS reporting. So you said you don't have to report unless it's 0.1%. No, it's you report, you do report under 0.1, but you report the maximum concentration. So if you have a refrigerator and a remote control and it's 0.01, PTFE is 0.01% of the refrigerator and 0.1% of the remote control, you report the 0.1%. Not that you don't have to report the 0.0, but you have to report the maximum concentration. So that's the max. It's also an interesting simplification. It's the maximum concentration in the product. So that's why you do have to report if it's under 0.1 if it's the maximum concentration, but by and large, there are the higher concentration uses. Now, there'll be a lot of cases, you got big products, and all you sell is big products, where a lot of them are going to be all under 0.1. It's kind of easy that way. But no, there's no de minimis. It has to be reasonably ascertainable. And a lot of products, because it's at the product level, not the component level, it'll be under 0.1. It just happens to be the pull down. Under 0.1, reportable, it's just one of the pull downs. 0.1 to 1% is an option. 1% to 10%, 10% to 30%, 30% to 100%, which is going to be pretty rare for articles. It's just pull down menus. So it's the max concentration. I read that the only exemption to PFAS reporting for US EPA is domestically sourced articles as part of a bomb. Is that accurate? So it depends what you mean by exemption. EPA doesn't have control over a lot of things. It doesn't control military completely, and doesn't control anything that's FDA regulated. So the exemptions are from what EPA controls. So domestically sourced articles are not exempted per se. It's just somebody else should have reported them as being imported. So it's just an avoidance of double reporting. But if it's not EPA controlled, then it's not in scope. So if things that are not exempted because they're not in scope, like medical devices are not in scope of EPA control. And that's why when you do the CDX, you can report medical, but it's actually under the category use non-TSCA medical. How does the US reporting portal look like? Is there anything similar to Skip portal? Nope, totally different. It looks like, if you've ever done CDR reporting, it looks like CDR. If you've ever done CDX reporting, goodness help you, I have. It's different. But one of the things, by the way, is if you're a US national, so what ends up, when you do the reporting, you're gonna be reporting as an individual for a company. So your CDX account is linked to you, and if you're a US citizen, to your social security number, real thing. And then that gets linked to the company, and the company or you has to remember, if you leave the company, to sever you from that. Canada's the same way. It's a GC code, Government of Canada code. So when you do like the Section 71 report in Canada, the code is attached to the person who then's attached to the company to report. Same thing here. You have your own CDX account, which gets attached to the company. It has to be justified by a signing authority of the company that you can report, and then you can report, and it's their responsibility to sever you from their account if you leave. If you're non-US national, you can, just when you go in to sign up for CDX account, Feel free to go through it. You get to a point where, okay, enter your US social security number. You don't have one, you're foreign national. So then you have to print out this piece of paper and sign it and snail mail it to a location in the EPA. They don't tell you to afterwards. If you get it notarized beforehand, it'll go through faster. But if you're not a US national, you can't use your social security number, and it's a whole other process where you mail in a form and you don't know if it works until you suddenly get approved by email. Totally different system. Does this apply to all products, even though it's installed into airplanes? That's a good question. Aerospace is generally in. Military is sometimes not. Aerospace is very commonly inside all TSCA requirements. It gets really more complicated though. If like the plane is actually, you know, sold to their entity in Germany and is flown around the US, that's somebody else's problem. Understanding that problem. It's for items you either import into or you integrate the chemical into in the US. So theoretically, if you assemble in the US, somebody else imported the components, it's their problem. If you've imported components to go into your product, you're responsible for what you import into the US. Sometimes it might be easy just to report your product anyways. You're allowed to double report. But it's normally articles imported into the US. But it's pretty well everything. So what happens, you make it in the US and gets exported. If it's articles you integrate and then export, that's not a problem. You won't have to report it. If it's a chemical that you coat onto your fabric to make it waterproof in the US, you'll be doing a chemical activity and you'll have to report that. Otherwise, you're just integrating. You only have to worry about what you import. If you export, you don't have to worry about anything. So if you make it in the US, it's physical product. Anything you're integrating, you're only responsible for what you've imported to integrate, or if you do a chemical process, you code it yourself, then you do. Perfect. I think I'm a little over time. Any other questions, feel free to report. Is Claigan report to CDX for companies after testing is performed? We'll give you exactly what to report. The reason we can't is the whole legal thing with CDX. It's going to want a individual who then is, you know, you have to sign 5 ways from Sunday, is authorized by the company to report to do it. We can, believe it or not, do it for you, but it involves like your executive signing off on us doing reporting. Or you do the reporting and we give you the exact data fields to put in, and when you do it, we can web link in with you. Because chances are your company would probably want to keep control of its CDX account. What we normally do is give you everything you need and then web in with you. And we can do it with you or literally for you when you do it. So we set you up to do it. Here's the data set. And if you need help, we can web link in with you and do it. The hardest part actually for some people off the bat is just getting the CDX account. We set up our data, so the reporting is usually not too bad. It's pretty easy. Getting the original CDX account is a bit of pain. Perfect. Well, thanks much. Can you clarify the percentage options available again? There's an under 0.1. So it's like, in the safety data sheet, you normally don't have to report anything under 0.1. This one you do. Under 0.1, 0.1 to 1, 1 to 10, 10 to 30, and 30 to 100%. Anybody who's a quarterly or monthlies will actually have it all listed out. Anybody who's ever done testing with us, by the way, for PFAS, the sheet will have it. If you've done it before with us and the Excel sheet we gave you for reporting didn't have it, feel free to just contact the engineer and he'll update it for free because it's just their process for us. And then we can add the percentages. So the modern sheets we have the percent in the component, because you might need it for some jurisdictions, and the percent in the product, which pull down it is. Well, thanks muchly. It's a great question. Pleasure. Is there an EPA toxic release inventory reporting requirement for PFAS? Last one, I believe there's something like that, but it's under this, I believe it's under the CDR side. The final rule has this whole description of how CDR and CDX are separated from here, and someday they might put them back together, but toxic release inventory is normally under the CDR, not CDX. Whatever. There's a whole dialogue in the final rule. The final rule is like a meandering conversation. It takes a while to figure out where they're getting to. But normally toxic release inventory, I believe, is CDR. Because I don't have a factory in the US, I normally don't have to do it. But it's a different system by the same people. Perfect. Well, thanks muchly. And we should get slides out to everybody to register pretty soon. And when in doubt, just reach out. We're happy to help. And if you've tested with us in the past, we have a really good way to update your product to current compliance. Talk to you later and look forward to talking to everyone again soon.